Hello everyone and welcome back to the channel. Every time you browse a website, send a message or stream a video, you're interacting with a system built upon a fundamental architectural pattern, which is client server architecture. It's the bedrock of nearly all networked applications, from simple websites to complex cloud services. In systems and interviews, understanding client server isn't just about defining it. It's about recognizing it as the starting point for building scalable, secure, and resilient systems. Today, we are diving into the foundational concept of the client server architecture. Okay, so let's start first about talking about what is a client server architecture. I will need my pen here. Okay, it's pretty simple. We have a client. Oh, where is the pen? Yeah, we have a client. We have a server. Okay, at its core, client server architecture is a distributed computing model that separates computing responsibilities between two main entities, clients and servers. Let's start with the clients first. The clients, these are the requesters of resources or services. They initiate the communication. They initiate the communication. The servers, these the providers of resource or services. They wait for requests from the clients, process them, and then sends back responses. Okay, it's pretty simple to understand. Okay, let's talk about the key components. Again, we have a client, we have a server, and we have something in between. We call it the network. Okay, so let's talk about the client first. The client here, this is application or device that initiates the request, like maybe your web browser, like using like Chrome or Firefox, maybe a mobile app, and like using Instagram or banking app, or a desktop application like Microsoft Word online or something like that, or an IoT device or maybe other service. Next, we have the server. This is a powerful computer or program that listens for incoming requests, process them, and delivers responses. Example for that, maybe you have like a web server like in on Nginx or Apache. You have an application server like Node.js, Java Spring, Java Spring Boot, or maybe you have a database server like MySQL or PostgreSQL or MongoDB, things like that. So basically, servers usually run on powerful machines in data centers designed to handle many concurrent requests and manage large amount of data. Next, we have the network. The network, this is a communication medium that connects clients to the server. Maybe we have like an example for that would be the internet. That's it, yeah. Or maybe you have a local area network like a LAN, or a wide area network like WAN, or WAN. It's the channel through which requests are and responses actually are traveling. Okay, how does it work? We need to talk about that. So we have the client, we have the servers. First, the clients will send the requests. The clients will send the requests. The client initiates communication by sending a request to the server. This request specifies what the client wants. Maybe like using HTTP GET requests, maybe for a web page, or a API call to fetch users' data, or maybe like a query for the database, or maybe like a write operation, things like that. The server will send a response. The server will receive the request. It then performs the necessary operations. It might retrieve data from database, perform complex computation, interact with other services, or generate dynamic content. And after that, the server will send the response to the client. Once the server has processed the request, it sends a response back to the client. The response contains the requested data and status code. Lastly, we have the client receives and displays the results. So the clients once the client received the response, it will parse the data and then display it to the user, or perform a subsequent action based on the functionality, basically. Okay, so right now we know what is a client server architecture, how it works. We need to know its advantage because it's the foundational of system design. The first thing we will talk about, which is a centralized data control. Basically, data and core logic reside centrally on the server. This simplifies data management, security enforcement, and applying updates. Number two, scalability. Servers can be scalable independently to handle increasing request loads, either by making a single server or more powerful virtual scaling machines, or adding more servers, which is basically horizontal scaling. Number three, sorry, security. Basically, data is primarily stored and managed centrally on the server, making it easier to secure and control access to sensitive information. Number four, maintainability. The clear separation of concerns allow client and server components to be developed, updated, and maintained independently, as long as their communication contract, which is the API, remains stable. Number five, cross pattern compatibility. A single server can serve various types of clients like web browsers, mobile apps, desktop applications across different operating systems. Lastly, resource efficiency. Clients can be thin clients that leverage the powerful processing capabilities of the server, making them lightweight and easy to deploy. Okay, what are the disadvantages and key considerations of the client server architecture? The first thing is a single point of failure. And in its simplifies in simplest form, if the single server crashes, the entire system becomes unavailable. This is mitigated by redundancy and replication. Also, number two, we have network dependency. It requires a continuous and reliable network connection between the client and the server. Basically, if you have no network, no service, yeah, it is what it is. Like I guess all systems like that, everyone is dependent on the network. So it's not a disadvantage, but like you have to know it because you might be asked something like that in your system design interviews. Number three, congestion and latency. So, heavy traffic can overwhelm the server or the network connection, leading to bottlenecks and increased response times. Network round trip time always adds latency. Lastly, we have cost. Powerful servers and scalable infrastructure can be quite expensive to acquire and maintain at scale. Okay, so client server architecture in system design interviews. So, in system design interviews, a client server architecture is typically the default starting pattern or the default starting point for discussing web or mobile systems. Interviewers expect you to go beyond the basic definition and show how you would build upon this foundation to address its disadvantages, like the single point of failure. Basically, you will add load balancers and server replications, and you add multiple instances of the servers. In terms of the performance and latency, like basically how would you incorporate cache layering, CDNs, or explore asynchronous communication patterns? In terms of scalability, basically how would you move from vertical to horizontal scaling, potential adopting a microservice architecture, things like that. In terms of security, how would you implement HTTPS connection protocols, authentication and authorization and permission as well? Lastly, it's the basically I would say it's a base from which you demonstrate your ability to design a complex and resilient system. So you really need to understand it. So yeah, that's it for this video, and see you in the future, guys.